Hey, good afternoon, calculus class. So this one is the video for sections 5.5 calculus. Okay, so it's about the substitution rule, part 1. So we're going to divide into two parts for this because that's going to be a lot of content here. So I really want you to take the time to watch both of these videos. So make sure that you guys understand, the concepts and also the way that I put in find the integrals. Okay, so let's take a look at that. So integrals of f of g of x, so the composition functions like phi times the derivative of g of x, which is g prime of x. So the way to set it up, so that's the integrals of f of u du. So this one is just the indefinite integral. So again, indefinite integral, that means there's no boundary for the lower bound and the upper bound. So that means once you integrate it, make sure that you need to add the constant c at the end. And now for the other part of it, it's the definite integral with the substitution rule. So let's say that integral from a to b, f of g of x, and then times g prime of x dx, so that would be the integrals of f of u du. So from the boundary, so as you can see that instead of using a and b, we're using that g of a and g of b, because that we change the boundary, so while you're changing the variable for the substitution. So you see that in a minute. Okay, so those are the main formula that I need to recognize for this. So in case that we're going to have a formula quiz like this. And then the other part of the properties I need to know, integrals of symmetric functions. So remember back to pre-cal, we do have an odd-even function. So once you deal with the odd-even functions, so for the even functions, so f of negative a to a, f of x dx, then that'll be 2 times the integral from 0 to a, f of x times dx. So let's say that we do have a symmetrical functions. Okay, so let's say like this, kind of like a sine curve. So instead of finding the area from a to a, we can just find the area from 0 to a. And then multiply by 2, because that they're both considered equal. Now what happens if that's odd functions? So let's say we do have something like this, like a cubic curve. So let's say that you need to find out the area from negative a to positive a. So what happens once you combine those two areas? So part of it, because this one is underneath the x-axis, so this part right here, it's right above the x-axis. So if you try to analyze it, anything underneath the x-axis, the area will be negative. And then anything right above the x-axis, the area will be positive. So once you combine them, so negative, positive, so basically pretty much to even everything out. So we just have 0. Okay, so now let's do some example in a minute. But let me check one thing real quick here. Okay, looks good so far. So now let's integrate the following functions by using substitution. So non-calculator, it's all doing it manually. Okay, so anytime that you deal with the inner functions, guess what you have to do? So back to what we did for the derivative, you want to set that as u. So u that equals 2 plus x to the power 4. And then you want to find out what u prime is, or du, either way. So u prime, then that'll be 4x to the power 3 dx. Okay, again, u prime is the same as du, the differential. And now compare and contrast. So we do have x to the power 3 dx. So this one is part of the du. The one thing that's missing here is 4. Okay, so for those you might be wondering, we don't have 4 right here. Can we make it up? Definitely you can make up that number. So 4. So we need 4 here. But in order to make up the number, you want to even that number out. So that means multiply by 1/4 outside. Okay? So 4 is part of the integrand. That's what we need for the substitution. So once you rewrite it, so we do have 1/4 times the integral of this, u to the power 5. Again, 4x to the power 3 dx. So that's considered du. And now, instead of integrating it with respect to x, we're integrating it with respect to u. So that means u to the power 6 over 6. Don't forget to bring down the 1/4, and then plus constant c. And then for the final step, guess what you need to do? You need to plug everything. So 1 over 4 times 1 over 6, that would be 1 over 24. So u, which is 2 plus x to the power of 4. And then plus constant c at the end. Okay, so that's what we got. So now let's try another one. So for part B, so for that one we do have cosine theta to the power of 3 times sine of theta d theta. And for a lot of students kind of confused about, well, what do we need to set up for u and u prime? Again, u would be considered an inner function. So anytime they see like inner function involved, most likely, so that element, it's going to be considered u. Okay, so for u right here, we just rewrite it. So we do have cosine of theta, quantity to the power of 3, sine of theta, d theta. As you can see that here, so u would be cosine of theta, because that's the only inner function we have right here. So u prime, or du, so we do have negative sine theta, and then d theta. So basically, simply take the derivative of cosine of theta. Again, compare and contrast. So back to the original integrand, so we do have sine theta, d theta, but we're missing negative. So that means we need to make up the negative sign. So we need to make up the negative right here, negative 1. So outside, we need to multiply by negative 1 as well. Substitute in, so we got negative 1 integrals of u to the power of 3. Again, this whole thing right here, it's considered u prime or du. Okay, you can put it either way. And now let's integrate it. So it's negative, so u to the power of 4 over 4 using the power rule plus constant c. And guess what you have to do at the end? Unplug. So u, which is considered cosine of theta, so negative cosine theta to the 4th power over 4 plus c. And that would be the final results of this integral. So you see that anytime they deal with the complicated functions or the complicated integrand and try to integrate it, so it's better for you to use the U-Substitution. So now let's try C, D, E, and F. Okay? So for C, D, E, and F, so this one's getting a little bit complicated. So for C, inner function, we want to use that u as the inner function. So x to the power of 3 plus 5. Okay, let's just put it right here. And then, so A and B, since we're done with those two, let me just erase those two. Okay, so this one for C, we do have x squared, x to the power of 3 plus 5 to the power of 9 dx. So u is x to the power of 3 plus 5. So u prime, which is 3x squared times dx. And for those who might be wondering, why do I need to put in dx? Remember, if x is considered a new function by itself, if we take the derivative implicitly, we need to follow along with dx. Okay, so now the next one, substitute in. But before you substitute all the element, we need to find out the missing number. So part of that u prime, we do have 3. So we need to make up that number. So multiply by 3. And then outside, we need the reciprocal, so which is 1/3. Well, the reason why that is because we need to even out the number. So we don't change the value of the expression, but we can change the look of the expression. So 1/3, so integrals of u to the power of 9, 3x squared dx, that's u prime, so put in u prime. Integrate it, so we do have u to the power of 10 over 10, but don't forget about that 1/3, bring it down, and then plus constant c. Again, it's an indefinite integral, so we need to add the constant c at the end. So in substitute, we got 1 over 30, so u, which is quantity, x to the power of 3 plus 5 to the power of 10, and then plus constant c. So this one is not that bad. And now what about for D? So for D, it's quite similar. So we do have integrals e to the power of x, sine of e to the power of x, and dx. Okay guys, don't be freaking out with the inner functions, exponential expressions, and also the trig functions for the outer function. So this one, basically, we just follow with the same kind of technique. Okay, so again, u, we want to use that e to the power of x. Inner functions, so u prime, it's also e to the power of x, but don't forget dx, the chain rule. So we got e to the power of x dx for u prime already. So basically, there's no need to find out any missing element. So we just need to substitute in. So we got sine of u times u prime. Integrals of sine of u, which is cosine of u. Well, actually, it's negative cosine of u, because derivative of cosine of u is negative sine u. and then negative, negative, positive, and then plus constant c, so negative cosine of e to the power of x plus c. Again, the final step, you want to unsubstitute u. Okay, so now what about for e and f? Okay, so to look at that, e and f. So for e and f, we do have some kind of weird expression. It's a rational. So again, anytime they deal with that a, b, c, and d, they're just considered arbitrary constants. Okay, so the only variable we have is just what? X and y. Okay, so now let's look at this. So for e, so integrals of dx over ax plus b, a cannot be 0. And then for part f, we do have e to the power of x, integral of e to the power of x, times square root of 1 plus e to the power of x dx. And for those who might be wondering, so what the inner function is for this part of the integrand here, so what's the inner function? So the inner function would be considered 1 over ax plus b. Again, dx, that's just considered the indicator. Okay, so let's just rewrite it. So that means for u, I would say that it's ax plus b. Because 1 over u, then that would be the whole function. And then u prime, so which is derivative of this, and that would be a times dx. So now we got dx for u prime, but we're missing a here on top, so we need to make up the element, so times a. So that means outside we need to multiply by the reciprocal. And then substitute u, not unsubstitute yet. Okay, so this one is 1 over u, and then times u prime. You guys do remember the integrals of 1 over u? That's right, it's natural log of absolute value of u. And then plus constant c at the end. Don't forget, unsubstitute, so we got 1 over a times natural log of absolute value, ax plus b, plus constant c. Well, here's another thing you can check. Once you find out the results for the integral, you can always take the derivative of this. Once you get the derivative, you'll get back to the original integrand. So check it out, derivative of natural log of this, which is 1 over ax plus b, times 1 over a, chain root for this one, times a. So a and a got canceled. Derivative of constant c, that's nothing. So we just get back to the original integrand. So now let's try the next one. So this one, inner functions, well, let's just rewrite it first. So for those who don't like to see the radical form, you can always convert it back to the exponential form. So we do have u equals 1 plus e to the power of x. So u prime, which is e to the power of x dx. Okay, so we write it. So we do have integral. So u to the power of 1/2. So e to the power of x dx, which is u prime. So everything's given here. So there's no need to make up any missing element. Just separate it, so this one is 2 different problems. Okay, so integrate this. Indefinite integral, so u to the power of 1/2 using the power rule. So we do have u to the power of 3/2 divided by 3/2. So in other words, multiply by the reciprocals, multiply by 2/3 plus constant c. Unsubstitute, so we do have 2/3 times u to the power of 3/2. So u, which is 1 plus e to the power of x, quantity to the power of 3/2 plus constant c. And that's the final result. Okay, so again, any questions that you have, so make sure that you put it into the YouTube channel, comments. So that's how we get participation points. And also people that you want to refer to, and also get the participation point. Alright, so I'll see you guys for the second part of the video later on today. Take care.